How's it, grade 12? So I'm going to be going through exercise 9.3 with you, with the ones that I've highlighted. Okay, so if we look at number 1, we've got y is equal to minus x cubed plus ax squared plus bx plus c. And we have turning points at this 1, 4 over here, and then minus 1, 0. We need to determine the values of a, b, and c in that equation there. Okay, so what I'm going to do, so this is exercise 9.3, and we're doing number 1. Okay, so we got y is equal to minus x cubed plus ax squared plus bx plus c, and we have turning points at minus 1, 0, and 1 and 4. Okay, and just for simplicity, I'm just going to say that f of x is equal to this. It's just the same thing. Okay, now because they've given us the turning points, what I'm going to do is I'm going to find f dashed, because if I find f dashed, remember that is finding the gradient, and if I set it equal to 0, well, that will find our turning points. So f dashed of x will be equal to, and we just differentiate this, minus 3x squared plus 2ax plus b. Okay, so if I know that f dashed of minus 1 will be equal to 0. Now, grade 12s, it's not this 0 that I'm setting it equal to. I'm setting it equal to 0 because I know that the gradient at this point is 0. Okay, and that's why I can do that. Then f dashed of 1 will also be equal to 0 because this is a turning point. The gradient is 0 at that point. All I have to do now, plug in minus 1 into there, and we get minus 3 minus 1 squared plus 2a minus 1 plus b equals 0. And I'm going to do the same for this one. Just plug 1 into here, minus 3 1 squared plus 2a1 plus b equals 0. Let's simplify this, so that gives us positive 1 minus 3. That will give us minus 2a plus b equals 0. Here that'll give us 1, so that's minus 3 plus 2a plus b equals 0. Okay, if I get the b on its own here, I get b is equal to 2a plus 3. Call this equation 1, call this one equation 2. So I'm going to sub 1 into 2. So wherever I see a b here, I'm going to replace it with 2a plus 3. So we get minus 3 plus 2a plus 2a plus 3 equals 0. So then that will give me 4a. Then that will give me 0. So that's equal to 0. So a is equal to 0. I'm going to plug this back into equation 1 to find b. So sub into 1. So we get b is equal to 2 times 0 plus 3. So b is equal to 3. Okay. Now I'm going to come back up to here, and I'm going to put my a and my b into there. So we get y is equal to minus x cubed. Now our a is 0, so that falls away. Our b is 3, so that's plus 3x plus c. All right. So all we have to do now is we just have to find what the c value is. Now all I have to do is just plug in one of these 2 points into here. So I'm just going to choose the top one. So we get minus 1, 0. So y is 0 equals minus 1 cubed plus 3 times minus 1 plus c. So that's 0 equals, that's minus 1, that's plus 1. That's going to give us minus 3 plus c. That's minus 2, so c is equal to 2. And we've got our a, b, and c. So a is 0, b is 3, c is 2. So I'm going to go on to now question 2, which is very similar to question 1. Okay, so in question 2, it's telling us that we've got y is equal to x cubed plus ax squared plus bx plus c, has turning points at 0, 4, which is over there, and then 2, 0, which is over there. Determine the values of a, b, and c. those values over there. Okay, so very similar to the first one. We've got y is equal to x cubed plus ax squared plus bx plus c, and we have turning points at 0, 4 and another one at 2, 0. Okay, and just like I did with the first one, I'm just going to say f of x is equal to this. It's just easier with the notation when we differentiate in that. So here, let's differentiate. So f dash x is equal to, now the reason why I'm finding the derivative of the function is because I have the turning points. Okay, so we get 3x squared plus 2ax plus b. All right, now I know that f dash of 0 will be equal to 0 because that is a turning point and our gradient there is 0. And then I also know that f dash of 2 is 0 because again it's a turning point. So if I just substitute 0 in here, I get 3 0 squared plus 2a times 0 plus b equals 0. Over here I'll get 3 2 squared plus 2a times 2 plus b equals 0. So that will fall away, and we're just left with b is equal to 0. I'm going to take that b and plug it into here. First of all, what I want to do is just simplify this. So that'll give us 4, that's 12. That'll give us plus 4a plus b is equal to 0. So now I'm going to take this b, plug it into here. So we get 12 plus 4a plus 0 is equal to 0. 4a is equal to minus 12. So a is equal to minus 3. Now that I have my b and my a, I'm going to plug it back into here. And we get y is equal to x cubed. Our a is minus 3, so that'll be minus 3x squared. Our b is 0, so that falls away. And then we just get left with plus c. Okay, again, to find c, I plug in one of these 2 points. So the point I'm going to just plug in is just this one over here, the 0, 4. So y is 4 equals 0 cubed minus 3 times 0 plus c. So that means that c is equal to 4. So we have our a, we have our b, and we have our c. All right, going on to question 3. So what happened here at grade 12 is I started recording and then it's just stopped recording for some reason, and that's why I've already written stuff on here. But I'll explain it as I go along. Okay, so the question is, y is equal to x cubed plus ax squared plus bx plus c cuts the x-axis at 1 and minus 1. So we got an x-intercept there and there. Okay, we also have a turning point at 1, 0, which is this over here. All right. Question A. We need to show that A is minus 1, B is minus 1, and C is minus 1 in this equation here. All right. So if I have a look at what they've given us here, they've given us the x-intercepts. So here we've got 1 times x-intercept, which is that minus 1. Over here, because the graph turns on our x-axis, that means that we have 2 x-intercepts there. Okay, so I have 2 times x-intercepts there. Now, that'll always happen grade 12s. If the graph turns on your x-axis, you will get equal roots. In other words, 2 x-intercepts. So we're given 3 x-intercepts. So I'm going to be using this equation here. So this is number 3a. Y is equal to a, x minus x1, x minus x2, x minus x3. Those are our 3 x-intercepts, okay? And what I'm going to do is I'm just going to plug them in. So if I plug in minus 1 into there, I'm going to get x plus 1. So y is equal to a, x plus 1. If I plug in 1 into there, I'm going to get x minus 1. And again, I've got 2 of these because we have 2 of those same x-intercepts, so it's x minus 1. Now, what we need to do is we need to find this a value. And what they've done is they've secretly given it to us. If I look at the general equation of a cubic, it is y is equal to ax cubed plus bx squared plus cx plus d. That is our general equation for a cubic. So when I'm talking about a, I'm not talking about this a that they've given us here, because their a is actually the original b. Their b is the original c, and their c is the original d. Okay? So a is actually the number in front of the x cubed. So if we have a look at the number in front of x cubed here, there's an invisible 1. And that is what a is. It's not this a value that I'm talking about. It's the one in the original. So that is what this a value is over here. This a value will be 1. So we'll get 1 times x plus 1, x minus 1, x minus 1. Okay? So 1 times this anything will just give us that anything. So y is equal to x plus 1. And what I'm going to do here, grade 12, is just FOIL these two brackets here. Okay? So we'll get x squared minus 2x plus 1. Now I'm going to distribute that x into each one there and that 1 into each one there. So we get y is equal to x cubed minus 2x squared plus x. Now I'm going to distribute the 1. So plus x squared minus 2x plus 1. Get like terms together. So it's x cubed. That and that will give us minus x squared. That and that will give us minus x, and then plus 1. Okay? So now we're ready to answer their questions. So a is equal to, b is equal to, and c is equal to. So in their equation, their a is in front of the x squared. So what's in front of our x squared? Minus 1. Their b is in front of the x. So what's in front of our x? Minus 1. And then their c is the constant term, and our c is 1. So we got a minus 1, b minus 1, c 1. A minus 1, b minus 1, c 1. So we've got that question right. Let's have a look at question B. Okay, so question B is asking us to find the coordinates at B. Now remember, B is a turning point. So how do we find turning points? We find the derivative and we set that derivative equal to 0. Why? Because our gradient is 0 at turning points. Because they've given it to us in the form y, I must find dy dx. And I set that equal to 0 because our gradient is 0 at turning points. So let's differentiate this. We get 3x squared minus 2x minus 1 equals 0. Okay. And what I can do now is I can factorize that, and we would get x minus 1 and 3x plus 1 equals 0. And then we can solve for this. So x is equal to 1, or x is equal to minus 1 over 3. Now, there's one turning point, but we already knew that because we can see here on the graph. So we're not interested in this one. So this one is not applicable. Now, the b value we can see is on the negative x-axis. So this x equals to minus 3 makes sense. It should be a negative. Okay? And remember the question was find the coordinates. So what I need to do now is just find out what the y value is. So I take this x value and put it back into the original. So y is equal to minus 1 over 3 cubed minus 1 over 3 squared minus 1 over 3 plus 1. If you put that on the calculator, you should get 32 over 27. So the coordinates of B are minus 1 over 3 and 32 over 27. Okay, so that is the answer for question B. Going on to question C, it says determine the equation of the tangent to the curve at x is equal to 2. Okay, so we are interested in finding the equation of a tangent. Now remember, a tangent is a straight line, so y is equal to mx plus c is its general equation. So we've got two things that we need to find there, and that is the m and the c. Okay. So what I'm going to do first is I'm going to find out what is the gradient at this point. Okay, and remember how we find the gradient at a point. We use calculus and we use the derivative. So we have the original function, and the original function was y is equal to x cubed minus x squared minus x plus 1. Okay, and I can use this because I know that this tangent is going to touch the graph at x is equal to 2. That's the point that we're interested in. Okay, so I know that the gradient will be equal to dy dx, okay, which is the derivative. So let's find the derivative. So it's going to give us 3x squared minus 2x minus 1. And we are interested in this point here. So I'm going to take this x value, put it into here, and that will give me the gradient at that point. So m is equal to 3. 2 squared minus 2 minus 1. So let's just quickly do this on the calculator. So we've got 3 squared minus 2 times 2 minus 1, and we get 7. So our gradient is 7. So now I know y is equal to 7x plus c. So I've got the one thing, now I just need to find the c value. In order to find the c value, I need to know what the point of contact is. All right, I know what the x value is, I just don't know what the y value is yet. So if I take this x value, put it into the original, I can find the y value. So y is equal to 2 cubed minus 2 squared minus 2 plus 1. Put this in the calculator quick. So we've got 2 cubed minus 2 squared minus 2 plus 1. And we get 3. So therefore the point of contact is 2, 3. I'm just going to take this, plug it into here. So we get 2, 3. So that means our y value is 3 equals 7 times 2 plus c. So 3 is equal to 14 plus c. So c is equal to 3 minus 14, and we get minus 11. Therefore, the equation of this tangent at x is equal to 2 is y is equal to 7x minus 11. Okay. Right, question D. It's saying for which values of x is the graph concave up? Okay, so for concavity, always use your second derivative. So let me just summarize here. This is concave up, this is concave down. To find concave up, you need to find your second derivative and set it greater than 0. Okay, for concave down, you need to take your second derivative and set it less than 0. Okay, so we are interested in concave up, which is this one. So I'm going to find the second derivative, f double dashed of x, and set that greater than 0, greater than 0. Okay, so if we have a look back here, we know that we've got our first derivative over here. There's our first derivative. So all I have to do is just differentiate this one more time, and then I've got the second derivative. So that will give us 6x minus 2 greater than 0. Take that to that side, and we get 6x greater than 2. Divide by 6, and we get x is greater than 1 over 3. So that is when it's concave up, when x is greater than 1 over 3. All right, so grade 12s, I think I'm going to leave it there for this video, and I'm going to make a part 2 for you guys. Okay.